Okay, so now that we got this the base simulation set up, let's look at setting up a PDG network. So I'm going to head out here to my geometry level. Actually, I'm going to split pane left and right so I can have them both open at the same time. And let's go here and let's make a top network. So top network is task operators. You can also you could probably just do it in there. So I'm going to dive in here. So this is our, the new kind of, well, I suppose it's not new anymore. The PDG. Let me just pin this to the viewport. Okay, set them both to 1, and then that will stay there, and we can visualize this. So yeah, PDG is procedural dependency graph, I think it stands for. So it's good for, we're going to use it for wedging, right? So to run a few wedges of these simulations to get some variations. You can use it for doing tests on simulations, trying out different parameters, or in our case to just get variations, changing noises and things like that. So let's just press P. We've got our scheduler there. We don't need to do anything with that. So first we just need the wedge top, and what we want to do in here is we want to create an attribute. Okay, so the attribute we'll call it seed. Okay, we'll create a seed that we can change for noises and things like that. Just trying to make some space here. And it will be a float. We'll give it a range, and just a big range is fine. 0 to 100 is fine. And then when we choose how many wedges, so I'm going to say 10, which is what I did initially. This is how many smoke simulations are we going to have? Are we going to run, right? So we'll have 10 values, and this will be split equally between 0 and 100. So the first will be 0 or 10, I'm not sure, and then 20, 30, 40, like that. All right, and if I do this to 5, it'll be 20, 40, 60, and so forth. Okay, so that's it for that. So now I can use this attribute in here, right? So if we go to, let's see, where can we use the noise? Don't think mountain has one. But we can use it in the offset, right? So if I come here, dive inside. Oh, make sure we run this as well. So if you just go to selected or output. So output C has got this orange flag on it. So we can do that, and you see we get this green tick, and now we have these 10 wedges. So we got 10 values calculated for this seed attribute, which obviously doesn't take any time. So yeah, if we can use that seed attribute now in the offset. So if I just put at seed there, okay, and then click on the attribute name to visualize it. And now if we try, yeah, you see if I go through these, we can visualize those different wedges, and you can see the difference. So as we cache this out, we can see the values that we will get. And again, if I change this 300, it should correlate. Oh, I'd have to I don't think that worked. I think we'd have to dirty. So if you right click and go to dirty and cook this node, and there we go, that's updated now, right? Yeah, so this number doesn't really matter too much. Maybe with an offset, actually, a low number, you'd get like a similar change. So a big number, I suppose, is better in that case. So wherever you've got offsets or seed attributes, we can put this in. So there's nowhere here. Let me just put scale there, just because we don't know what's going on there. Polyfill, add noise, definitely. So I don't think there is a seed attribute here, but again, we've got the offsets, right? So we can use that seed. Don't worry that they'll be the same, because it's like a different type of noise to the mountain. If we had 2 of these, then maybe I would change it. But you know, it's a different type of noise, different scale and everything, so don't need to worry that they'll have the same value, probably 266, and the same there. But that's okay. So we got that point velocity. We could do it. Yeah, we'll do it here as well. At seed, rasterize no. Let's see if there's anywhere in here. Maybe inside the wind, the turbulence. There we go. So we got a seed value there for the turbulence. So again, at seed. Okay, and that will pick up that same value. If you don't want to have the same numbers, then you can just do like add plus just a whatever random number, and then you'll get something different, but it really doesn't matter. Okay, so let's see what else we can do. So, you know, yeah, that's just kind of generating a random value, but let's say if we want to adjust the turbulence there or the wind, maybe we'll take a look at that. Okay. You know, obviously we don't just want a random value going in there. We want, you know, you can have a value list. So either this number, this number, this number, or we can have a tighter range. Okay, so if I do another one and call this wind. And then we need to be more careful with the range now, right? So if we do like 0.05 to 0.2, could try that. These are the values that, you know, I'll say now that, you know, this took a long time for me to calculate. You know, it was overnight and I only got 100 frames. That could be because I didn't change this. So this is only allocating a quarter of the cores on my CPU. So maybe change it to CPU count less 1, or you can just put in, you know, how many cores you've got. Maybe changing that, I think that will help it out a lot. But also be careful with these values. So, you know, 0.2, think about things that are going to make your simulation bigger. So more wind is going to push the pyro over, and you're going to get a, you know, quite a lot bigger simulation than a value of 0.05, right? These, like I said, these are the values that I went with. Got some nice variations, but might be worth doing, you know, a test with the max value. So maybe doing a test at 0.2 and see how long it takes to get, you know, like a couple of 100 frames. So yeah, bear that in mind. So now we've got that value wind. We just come in here and put at wind. And we need to do the same again. So right click, dirty and cook. So first one doesn't look, oh, we need to, there we go. So you see we got these values from 0.05 to 0.2, okay? And let's do one more for the buoyancy. So now it's here, the buoyancy scale. So right now, what do we have? 1.5. So another value, and again, it will be called buoyancy. And it will be a float and a range, and we'll do bits from 1 to, 13. From 1 to 3, and again the same as with the wind. You know, the more buoyancy you have, the higher the smoke is going to go and make your simulation bigger and slower. So take that into consideration. It's kind of a funny spelling for buoyancy, isn't it? Buoyancy. Okay, and then I think you can either do that, but if you've got lots of nodes, you can go, you can do it here, dirty all, there we go, and then do that, and then we should get some values, there we go, perfect. Okay, so that's, you know, we've got variation going on. Next we'll just look at caching this out.